The last topic we're going to cover in section 3.1 is the quotient rule. So we talked about the product rule already, and now we're going to talk about the quotient rule. So we learned how to deal with functions that are products, but how do we deal with functions that are quotients? And by this I mean something, for example, something that might look like, y equals 2x plus 3 over the quantity 5x minus 2 raised to the fourth. That's our quotient. You notice it's not simply just a 1 over an x or a 2 over x, something along those lines. We already know how to deal with those with our power rule. We already learned how to deal with that by moving, the denominator up to the numerator and giving it a negative power, and then just using the power rule to take care of that one, and using the chain rule if it's a function on the bottom instead of just an x. But what happens if we have a function in both the numerator and the denominator? In this case, when we take its derivative, again, the slope of our curve, which is the slope of our tangent line, is going to be affected by both functions, which means we have to take the derivative in some way of both f of x and g of x. In this case, the way we say it is that if we have f of x over g of x and we take its derivative, we take g of x times f prime of x minus f of x times g prime of x all over g of x quantity squared. Really not easy to remember. So the way that I learned this was that we call this one the high and this one the low. So the numerator is the high, the denominator is the low, and we can abbreviate that LO and HI. So the way I learned to memorize the quotient rule is to say low D high minus high D low all over low squared. And this is a pretty common practice in calculus courses from pretty much everywhere that I can tell. And it's a great mnemonic to remember how you find the derivative of a quotient of two functions. So low D high, so g times the derivative of f, minus high f times the derivative of the low g prime all over low squared, g prime of x squared. In our product rule, it didn't matter what order we put the terms in as long as we had one times the derivative of the other, and then we added to it and we switched them around. What's going to happen here, though, is we have to be very, very careful because of this negative right here. This negative in the middle means that order absolutely matters. So it has to be the bottom times the derivative of the top minus the top times the derivative of the bottom. So low D high minus high D low. It is really important to always get them in the right order. So let's try it with a simple pair of functions. Here I just used x plus 2 and x minus 2 as my two functions. So here we want to differentiate and we want to find dy dx. So if dy dx is low D high minus high D low all over low squared, if you can see that on the, the black band at the top, then let's see what we've got. So here's our low, here's our high, right? So low, x plus 2, times the derivative d of high, which is x minus 2, so d dx of x minus 2, minus high, x minus 2, d low, so d dx of x plus 2, all over low, x plus 2, quantity squared. So you can probably hear my dog moving around. She doesn't go very far from me these days. So if we continue, we've got x plus 2 times the derivative of x minus 2 is just 1, minus x minus 2 times the derivative of x plus 2 is also just 1, all over x plus 2 quantity squared. So really all we have to do is simplify the numerator into x plus 2 minus x plus 2, right, by derivative or distributing this negative. And then on the bottom we have x plus 2 quantity squared. So really what happens is these x's cancel out, and we end up with just 2 plus 2, which is 4. So our derivative here is going to be 4 over x plus 2 quantity squared. By now, you know me well enough to know that I'm not going to leave it as simple as that. So what happens now if we change a little bit, and now we have x squared minus 2 over x squared plus 2? Well, our derivative here, dy dx, is still going to be low, x squared plus 2, d high, which is going to be 2x, minus high, x squared minus 2, d low, 2x, all over low, x squared plus 2 squared. So we can either factor some stuff out. That's probably our best bet here. I mean, if we really wanted to, we could try to multiply it all out and combine like things and then factor. Kind of is a mess, but we can do that. Let's try it that way first. So 2x times x squared gives us 2x cubed, and 2x times 2 gives us plus 4x. And now minus, let's run a 2x through. 2x times x squared is 2x cubed. Minus 2 times 2x is minus 4x, all over x squared plus 2, quantity squared. Or we end up with 2x cubed plus 4x minus 2x cubed plus 4x, all over x squared plus 2, quantity squared. And again, we have something very similar to what happened last time. The 2x cubes cancel out, and we're left with 8x over x squared plus 2, quantity squared. The question is, what would it have looked like if we had factored? Well, if we had factored instead, here we would have said, all right, I'm going to take out 2x from both terms, because that's the only thing they have in common. And then I would be left with an x squared plus 2 minus, and then in parentheses over here, just the x squared minus 2. All of it is still over x squared plus 2, quantity squared. So we'd end up with 2x times, let's see here, x squared plus 2 minus x squared and plus 2, all over x squared plus 2, quantity squared. And you may have figured out already that's going to cancel out a little bit around here to give us 4. So we end up with 2x times 4 over x squared plus 2, quantity squared, which is also 8x over x squared plus 2, quantity squared. So you can see that it doesn't matter which method you choose in terms of simplifying, but you can simplify them both down in the same manner. Do I want you to simplify it this much on an exam? Yeah, absolutely. You're going to have to do some factoring and simplifying for all the product and quotient rules. Let's try one last example. Now, I don't have the same expressions on the top and the bottom with just a different sign in between. I changed it a little bit and said, let's put x squared on the numerator, but the denominator is now x squared plus 2, quantity squared. So let's see what happens when we start out with this one. So in this case, dy dx is going to be low, x squared plus 2, quantity squared, d high, which is 2x, minus high, which is just x squared, times d low. And this is where our chain rule comes in. Bring down the 2. We're left with x squared plus 2 to the 1 times the derivative of x squared plus 2 is 2x. All over low, x squared plus 2 squared, quantity squared. Now, this one might have gotten a little confusing for some of you because we are taking a function that was already squared and we're squaring it again. So remember that our low was already squared. So this whole thing now also has to be squared. Which means then, when we simplify a little bit, we end up with, let's see here, 2x, x squared plus 2, quantity squared, minus, let's see here, we've got a 2x, a 2x squared, and an x squared plus 2. I just combined a couple of terms. I didn't combine them all yet. And then there's x squared plus 2 now is to the fourth on the bottom. The other reason why I didn't combine all of them just yet was that I noticed that this has a 2x and this also has a 2x. So I kind of kept one of the 2x's out for a reason. And then we've got x squared plus 2 in both terms. But the lowest power is going to be the one on the right. It has a power that's implied of just 1. So we're going to pull out just 1. So we're going to pull out the 2x and just 1 x squared plus 2. What that leaves us with is another x squared plus 2 here, minus we took out the 2x, so 2x squared, and we took out the x squared plus 2. And it's all over x squared plus 2 to the fourth. Or we end up with 2x, x squared plus 2. And inside we'd have x squared plus 2 minus 2x squared. All over x squared plus 2 to the fourth. And I'm going to have to just write it to the side here, kind of ran out of space. Now we've got an x squared minus 2. So if I have 1 minus 2, this is where it might throw some of you off, is, let's copy these guys down first. 1x squared minus 2x squared is going to give me a negative 1x squared. So I'm just going to write it as a 2 minus x squared. And then on the numerator, or the denominator, we have x squared plus 2, quantity to the fourth. What some of you might have noticed by now is that we also have an x squared plus 2 to the 1 on the numerator, and x squared plus 2 to the fourth in the denominator. So the numerator has 1 and the denominator has 4. So we can take our simplification one more step down and say, okay, let's just cancel out one of those x squared plus 2's from the denominator with one of the ones that's in the numerator. So I'm left with 2x times 2 minus x squared on the top, and only x squared plus 2 now to the third on the bottom. And again, that's because I have 1 here and I have 4 on the bottom. So this would be the same as saying if I had x over x to the fourth, I can cancel this out by saying this is x over x times x cubed. And then those two x's just cancel out, so I'm left with 1 over x cubed. Notice we did the same thing here. But this has to be an entire expression that is the same. It can't just be that I have an x squared plus 2 somewhere in here. In order to cancel out an expression, the entire expression, or the entire function, if you will, has to be in both the numerator and the denominator. We'll practice some more with this when we get back together on Tuesday, and you'll have a lot of these to do in your homework. So you'll get a whole lot of practice on factoring.